Today I'm gonna take a look at a couple of Commodore 64s that are not working. Hello everyone and welcome back to Arctic Retro. Yeah, I got some packages on my bench. I got a lot of packages lately. This is not all of them. But in this video I have this package which has two Commodore 64s in non-working condition. That's what I was told, and a couple of other packages because I'm gonna build something that I need to test those Commodores. Yeah, I bought this from a guy here in Norway. It says forsiktig glass, it means careful glass, but I don't think there's a lot of glass inside here. Must be the fuse. Yeah, let's open this and see what we have. That's one Commodore, and there's another Commodore. Yes, that's what I got. Only the two machines, no power supplies, no cables, no nothing. I noticed in this one there's something loose inside. Before I do anything, I'm just gonna inspect the machines briefly and hook them up and test them. This one is quite yellowed. Has some spots of the original color. I'm gonna test that one first, and this one has some paint and some melted plastic marks, probably from cables. And underneath here it says, there's a sticker that says SID 6581 untested, keys tested okay, machine not booting. And the label here is loose, so it's been taped down there. This video is sponsored by PCB Away. In my videos I often have the need for some PCBs for my projects, and my favorite PCB manufacturer is of course PCB Away. If you need to have produced your own PCBs, then just head over to PCB Away, where you can upload your Gerber files directly, or you can choose from a wide variety of ready-made PCB designs. PCB Away can also support you in your other hobbyist needs, like 3D printing, CNC machining, sheet metal fabrication, injection molding and other services. So go ahead and visit PCBaway.com and check out their services. So I have no idea what this video is gonna become, since I don't know anything about these machines. Can become very short, both machines are working, or it can become very long, so it might end up just being repair of one machine. I paid only like 50 euros for both machines, I mean 25 for each. Okay, let's turn on the first machine, see what happens. Well, we have a black screen. Then the second machine, let me just quickly turn it on. The one with loose parts inside. Let's see. Oh, there's no LED. Well, it came on after a while. I heard like a click inside. But I'm gonna start with the other one. This one looks better and more promising. So first thing I'm gonna do is simply try the DesTest cartridge, see if there's any life in any of the chips at all. And talking about DesTest cartridge, that's something I'm gonna build pretty soon. The DesTest cartridge, the new version. Let's see now. DesTest can take a while to start, but apparently it's not starting at all. So when I turn it on, it goes from no signal to having a SCART signal, and that means that there is actually a video signal coming out of the machine, but it's black only, and there can be many reasons for that. Alright, let's take a look. Any missing parts? I specifically told the seller that if it had some missing chips or something, I didn't want them, but he said everything was there and it looks to be correct. Okay. Yeah, a lot of dust and dirt on these machines too. Yeah, so what do we have here? Well, it's a regular old 250 407 board. Everything looks alright. Some chips are in socket, C chip in socket, PLA, CPU, all the ROMs. Yeah, that looks alright. Okay, since this machine obviously has been worked on before, I am gonna check that all the chips are correctly seated and the correct orientation and everything simple like that first. Yeah, everything looks to be correct. Backside looks perfectly fine. There's some gunk here. I'm not sure if you can see it. You see that shadow there? Some layer of some kind of liquid has been spilled before, also over here. Yes, and the next step here would be to just check some voltages. On this variant there's two voltage regulators. There's the 5-volt regulator and the 12-volt regulator. So just checking voltage. Yeah, that's 5 volts out and it's pretty accurate. And then for the 12 volts, 12.1. Yeah, so that's perfectly fine. Let's check some of the chips then. Yeah, there's 4.7, a little bit low. And over here we can check on the user port. There's 5 volts there, or 4.78. So the next step then is to try and rule out some suspects. I can feel the seed chip is quite warm without it even making any sound, but the seed chip, even though it's not necessary to run the machine, can cause the machine to be dead. So take that out. See if that changes anything. No, there's nothing. I think one of the most usual faults when it comes to a black screen Commodore 64 is dead PLA chip. So before I do anything else, I'm gonna check that one. Hopefully it's not that, but I have a spare. I have a modern variant here, and yeah, just gonna check with that one, see if it makes a difference. Hard to get in, thick pins. Nope, it was not that easy, but I'm still gonna use the replacement here as I'm trying to figure out what's wrong. Then it's time to hook up the oscilloscope. I have this picoscope here that is connected to my PC via USB. I've probably seen it before. So let's see now, do we have anything here? I'm gonna check some of the signals on the CPU, the clock. Yeah, that's perfectly fine. We have some of the address lines and data lines. I'm gonna go through them all, see if something seems strange or missing. So here's the pinout for the 6510 CPU. I already checked all the data lines D0 to D7 and they all look fine. So I started to check the addressing line from pin 20 and upwards, 813, and here I see something strange. That's 813, looks normal. A12, well, that doesn't look normal. That's just some sawtooth pattern. 2 volts or below. 11, 10, 9, 8, 7, 6, A5, A4, A3, A2, A1 and A0 all look fine, and that's 5 volt input. So there's something wrong with address line 12 then, and without the proper addressing signal then a computer cannot work properly. It won't be able to address the RAM correctly or other chips, but it could of course be a fault in the CPU, or it could be some of the control logic for the address bus. So that isn't necessarily easy to figure out, but the easiest thing we can do is obviously just replace the CPU. It's in a socket already. See if that helps. So I'm gonna quickly replace the CPU with a working one, at least the one I think works. Worked the last time I tested it. It's this one. It has a heat sink on it. Okay, let's see now. Nope, still dead. So I'm gonna check the same pin, the address line 12, see if it's still the same issue, and yes it is. So then that fault comes from something else, another chip. So now I just need to check out the schematics. I start here with the RAM, and I see that the address line 12 goes to U13. It's 74LS257 on pin 14. Looks like a little bit hard to read, but I think this is A12 pin 14. And that is this chip, pin 14. Let's see now if we see something strange on pin 14. Yeah, it's the same sawtooth. Pin 13 is another address line, and that looks to be alright. This chip is not in a socket, and it might be easy to assume that there's something wrong with that chip, but it could be something else on the road from the CPU to this multiplexer, I think it is. It can obviously be another chip that is making that fault on the address bus. So to rule out something, I simply remove some of the chips that I can. The ROMs, they're easy to get out again. So if that makes the problematic signal go away, then we know it is one of those chips. Let's see now. Nope, still the same. So pin 14 on this multiplexer is an input, and it takes two inputs and provides one output, and the output looks okay on this. However, if the input is garbage, then the output will also be garbage, but the signal itself on the output is the correct levels. However, the address bus is connected to all the chips that needs the address bus at the same time. So yeah, we ruled out these. We have ruled out the SID chip. It could be the VIC-2, but I don't think so, because video and clock is produced by the VIC-2, and that looks to be alright. Then we have the CIA chips. These can also be the fault. ColorAM doesn't use the A12 address line. However, looking at the CIA chips, I see that they don't use A12. They only use A0 up to 3. Well, maybe I was chasing the wrong rabbit here. I actually figured I'd take out the DesTest cartridge just to rule it out of the equation, and I no longer get that strange signal, but A12 is always high. Then we have a totally different situation. Why is it always high? Is it stuck high because it's shorted to 5 volts or something? So from U13 pin 14 should have a connection there to pin 19 on the CPU, which we have. Do we also have a connection to something else? We don't have a connection to 5 volts. So something is keeping that high. Just to figure out what's going on, we get the address line 12 in on pin 14, and address line 4 comes in on pin 13. Those two are combined and then goes out on pin 12, and that is addressing the RAM. And that's also the same. It's this chip, you know, and on pin 14 here, it's all high signal coming from the CPU, pin 15. So that makes me wonder. However, if I insert the DesTest cartridge, that strange sawtooth signal comes back on A12, but then on A8, which also were high, there's no signal, so seems to be an issue with A12 still. Just to rule out some of the chips are not gone, I took out this board here. This is a Commodore 64 replica board that I built myself a couple of years ago. That was the time when my channel was called ovesen.net. Yeah, and now I have the CPU in, which came from the other machine. Yes, and that CPU seems to be fine. Nice. Then I don't have to worry about that. Now I'm gonna check the PLA. Even if I inserted the replica PLA, that should be working. I'm gonna test the one that was in the machine. Is that one? Let's see. Ah, that's black. Okay, so the PLA is not working. Put an X onto that. What about the replica PLA? Where is it? Yo. See if that's working. You never know with these modern components, they can also fail. Ah, that's working. Okay, so now I know that the PLA I have is working and the CPU too. Yeah, also you can see I replaced all the ROMs with some non-working ones, and I actually put the old ones in the new machine and they work. The nice thing with having a spare machine is obviously you can check on a working machine. So I know I'm checking the signals on the address bus. Yeah, definitely there's signal on all pins, and now I observe on the faulty machine that some of the address lines are just high. Also checked with the working SID and it was not any better, so it's not that. And obviously while I'm at it, I also checked the other chips that are in socket here and replaced them with working ones, and there was no difference. Alright, so this machine has multiple faults, and now we ruled out a lot of things. So what I'm left with then is actually some of these logic chips, the CIAs and the RAM, back to where it was, and now there's just a simple high signal on both A13, A12, not 11, not 10, not 9. Yeah, 9 is high all the time, 8 is high all the time. So I'm just gonna need to check the schematics and see where those lines go to, and if there's some common thing that can hang on those. Sorry for the background noise, my son is vacuuming downstairs. Anyway, there isn't much more involved on the address bus than the two decoding chips for the RAM. Everything else we have essentially ruled out, and we have of course the RAM itself, and the two multiplexers for the RAM is these two, and those are branded MOS 7708, and that's the same as the 74257. And of course these early MOS branded logic chips are known to be failing. So I think I'm just simply gonna solder out those and replace it with new ones. That's how it is with fault finding on these machines. You rarely get a definitive answer because so many things are connected together, and a fault in one chip can manifest itself in many other places on the board. We see low signals coming from the CPU. You could think it's the CPU's fault, but it could be another chip that's actually holding a line low or high. I marked the two chips. Let me just get them out quickly, just using a little bit of liquid flux here, just to make it easier to desolder. Yeah, they didn't come out just by using desoldering gun. Not always easy. Just use some additional heat. rip any pads. Yeah, I just took out both, even if it's probably just one that's faulty. It's out. Yeah, just clean up the mess. Some leftover old solder. Some sockets are in, and then just a little bit solder. Let me just quickly test the chips, see if they actually are faulty. That's good. Oh, yeah, for sure, that's faulty. Sometimes there's a bad connection. Yeah, definitely faulty. Okay, maybe we found the culprit then. Yeah, one was good, I just put it back. Well, now it depends if I find a working chip. Haha, there's 4 157s there. Alright, let's quickly test this now. Could of course check if the signals are correct first, but yeah, just turn it on. Nope, still a fault. Well, that's not unusual. Let me check the address bus now. 813, yeah, definitely that fixed that. 812 is still not good. 11 is good, so definitely some of the lines came back. I'm gonna replace the other chip as well. Okay, this is a brand new one then. Okay, we have something. We have a picture. So definitely those two chips were not good. So this is kind of a strange fault. I haven't seen that before, I think. Let's see if we just reset it. But now we should be able to use the DesTest. Yeah, it runs, but the graphics is not working correctly. And what could be causing that? Well, it could be a RAM issue, definitely. The diagnostics cartridge too, it comes up. Now the signals on the address bus. Yeah, they now look okay on all pins. So closer but no cigar. Okay, so I think it's time to check out the RAM, but usually the DesTest would indicate faulty RAM by some blinking, but doesn't do that. Yeah, more and more colorful. I'm just testing again with the DesTest cartridge. Anyway, now I'm gonna continue with the next part of this video, and that is to build a DesTest switch cartridge, because maybe that can help us diagnose the rest of this machine now. On with the build, and this is the package I just received from my sponsor PCBWay. And you know, it's very easy to order your own PCBs from PCBWay. If you find the project on GitHub or anywhere else where you can download the Gerber files, then you just simply upload it to PCBWay and do some simple selections, and then you quickly, after a few days, get your PCBs in your mail. Or you can check out their shared project site, where there's a lot of already made PCB designs, where you can simply put it right into their shopping cart and order them right away from the website. This is the PCB for the DesTest MAX-Switch, and if you don't know what that is, then I'll show you in a minute. Yeah, as you can see, it's quite simple design, and I got 5 because that's the smallest number of PCBs you can order from PCBWay, and these cost only $5 for 5 PCBs. Yeah, I got them in black, and yeah, they look very nice. Also, I got some other PCBs here, and yeah, This is for something completely different. This is for making sound cards for the ZX Spectrum machine, which I'm gonna do at a later stage in another video. The DesTest project is made by Matt, and you can find it on the webpage Factor of Matt. This is it. And he has made several projects, the DesTest and the DesTest MAX-Switch, which I'm gonna build now. And it's a max mode expansion port utility for the C64. And this is a diagnostics tester. Well, it's a full 64K memory tester, and I've seen it in use on several videos, and it looks to be quite useful. So that's why I thought I'll build this before I go ahead and try to remove any RAM chips on this machine. Yeah, and it's quite a simple build. You only need a EEPROM, a couple of logic chips, a couple of resistors and capacitors, a switch, and a couple of LEDs. And the ZX sound cards is also something he made, so I thought I'll build them as well, and that's gonna come up in another video, as I said. Yeah, even if the PCBs are cheap, only $1 a piece, you still have to pay for shipping, but I think I paid like $25 for shipping, and then it was delivered all the way to my door in a couple of days, so that was very quick. And the quality looks to be very nice. You can obviously get them with gold plating and stuff like that, and various other quality enhancements, but I choose to go with the basic here. And then we need a bill of materials to know what components to put where. And obviously we need some components. And I usually buy stuff from DigiKey because they're very fast and quite cheap. And the shipping is free if you order for more than around $45 US, I think. So this was shipped for free, but obviously I bought a lot of more stuff than just for the DesTest. If I first decide to order something, I get a lot of other things that I might need, or to fill up my stock of various things. Yeah, so I just need to sort out all this, and then I'll be back. They use an awful lot of plastics. I mean, it's bags within bags within bags. I mean, it's nice to have these anti-static bags, but no, I got enough of those for life, I think. And by the way, ordering components like this, it's very time consuming, because there's so many variants of everything. You know, like a capacitor, there can be 10 different types with the same values and all sorts of parameters and sizes, so you need to be careful. However, this was supposed to contain a speaker, but do you see a speaker here? No, just an empty bag. Well, I don't need a speaker in this project, so I guess I just contact them and they will send me a speaker. Once before I ordered a wrong part. It was not a part, it was more like a bigger thing, and it was the wrong type, and I just contacted them and wanted to return it, and they said, okay, we'll send you the correct one, you just keep the one you got. So now I have two. Yeah, what do we need for this project? Yeah, we need 3 capacitors, we need 6 resistors, 2 LEDs, 1 switch, 1 74LS74 chip, 1 74LS02 chip, 1 EEPROM, which I didn't get here. I have that from before. A couple of jumpers, and that's basically it. There's the capacitors. I always order a lot more than I actually need because they're dead cheap. So order 10 or 30, it doesn't really matter. And don't be afraid to order small quantities. You see, this one I only ordered 1 piece of a particular resistor. I take back the thing with the missing speaker. Apparently it has fallen out of the bag. So it's here. Yeah, you see a little speaker. Not for this project. Alright, I'm gonna build the first one. Yeah, it's quite simple. Here there's a switch there, some jumpers, 10k resistors, 100 nanofarad capacitor, 7402, 7474, the EEPROM, more jumpers. Yeah, if you followed my channel, you have seen me build a lot of projects like this. Start with the smallest components, and I usually just hold them in place with using some blue tack. And then it's just a matter of soldering in things. So I just want to give you some tips and tricks while I'm doing this. For example, soldering in a socket, you want it to be flush with the board on the other side. So I just solder the corners first. And then I just push it from the other side and resolder. And then it falls into place. Yeah, I felt it move a little bit. Perfectly aligned. And then just solder the rest of the pins. And with new boards like this, it's always easy. No issues. I don't have to use any flux or anything. You just need a good soldering iron and some good solder tin, which I have here. This is very thin and it's leaded. And leaded solder you can't buy anymore here in Norway, at least. Not private persons. I think businesses can buy it, but you don't find it anywhere. I found this some years ago on eBay, and it has been lasting me a long time, several years. Yeah, that was the socket. Now there's going to be 4 10k resistors. I'm using this tool, which I 3D printed, just to bend the pins correctly. Quite helpful. And then it goes into there. Yeah, perfect fit. Yeah, so you see how it works. I'm just gonna solder this finished, and then we can test it. So I'll be back soon. Yeah, the soldering is done, looking good. Now I just need to populate chips. There's a couple of jumpers here that is supposed to be set according to what kind of EEPROM you have, and that's written on the back side here. If you have a 27128, then A14 and A15 must be off. A15 is there, and A14 is there, and there's a 16K mode. You can read about this on the back here. I think I'm going to use 128, so I'm going to set it up for that. Yeah, and there's some jumpers down there too, 101, 102. I'm not really sure what that is. Yeah, so we have these 2 logic chips, and then the EEPROM needs to be programmed, and you can find the binary for that on his web page. Yeah, and I bought the chips from DigiKey 74LS02. I want the real chips, not the fake or non-working chips from China. And these are quite cheap. I think they cost around $1 each or something, maybe less. Yeah, now I'm gonna program the EEPROM. Yeah, and these I bought from AliExpress. Chinaware, very cheap, almost nothing. Came in a batch of 10. These are probably been pulled out of scrap boards or something. I'm not sure, they look alright. If they work or not remains to be seen. So if they're empty or not, I don't know. This is M27C128. Obviously you need an EEPROM burner for this, but these are quite cheap, so yeah. I think you get them for like $40 US now. Yeah, it's 27 and it's a ST. It doesn't list ST, but I'm pretty sure you can use the AMD. Let's see, blank check. Yeah, it's empty. There. Then just burn it. So the chip seems to work. Yeah, and it's verified. Let's verify once more, just to be sure. Nice. Yeah, that was it. Let's put it in the computer, see if it works. Let's see if this can actually display anything and tell us if there's something wrong with the RAM. Well, it seems to be running, but not enough to make any sense. So it has a reset switch. That works. Yeah, so what could be causing this? I know I tested kernel ROM and all that, but this DesTest should be able to run without the kernel ROM. So I'm just going to pull it out. I actually pulled out all the 3 ROMs. No, it's just black. Well, no, it is running. Yeah, it's familiar to what I've seen on videos from the DesTest, the color scheme and stuff, but yeah, what could be making that crazy graphics? So even if there's a fault on the RAM, this cartridge should start up. However, I did now read in the instructions that the jumper I01 should be jumpered for now. So I didn't do that, but let's see if that changed anything. Nope. I think I checked everything that is essential to check except the CIA chips, but they are rarely making these kinds of faults. So the ROMs are out of the question, CPU is working, weak chip is working. I know I inserted the one that I know is working from the older machine. We replaced these, we replaced these, we replaced these. I tested the other chips with working ones. This one is, the PLA is working, the SID is out. So all that's left, something having to do with the RAM or the data bus. Let me take a look at the data bus. Yeah, the data bus looks all fine. All the 8 lines giving a perfect signal. So that makes me wonder if there's something else wrong around here with some of the address and data bus logic here. So here's another 373, which is a latch. Let's see now. Nope. How about the 139 here? I have a new one here. Nope. Then the only 2 remaining chips that I haven't really tested is these 2, and this is 74LS08 or a MOS 7712, which is in this machine. Probably broken, and this is 258. By the way, this sawtooth signal I observe on address line 12. I'm not really sure if that's a fault. I checked the other machine that's working, and it looked kind of similar. Just gonna check this chip, see if it tests okay. Logic 7406. Yeah, look at that. Chip failed. Definitely failed. seems like it passes some of the tests. I mean, some of the logic gates are working, but not all. Okay, in with a new one then. Yeah, I try to always check new chips just to make sure they're okay. I don't think this is a new one, but I had it in my stash. Yeah, that passes. Nice. No, nothing. Anyway, that chip was definitely faulty, so it would probably make some other faults somewhere else. What about these stripes on the screen? So this was a hard one. The DesTest, it can run without any of the ROMs, but since it's running its code, that seems to indicate that addressing is working, and yeah, what can then be the fault? I just swapped the two multiplexers, the 257s, and now I get a different result. But we have these two chips. This is an old MOS chip, I don't trust it, and this chip here at 258 looks to have been done something with. There's a layer of something, hard flux or something on it and around. Instead of hunting anymore, I'm gonna desolder these two. That's a quick job anyway, so let me do that. Chips are out, let's see now. Start with a 258. Yeah, look at that. It passes some tests, but then it fails. Yes, that was something strange with that chip. Looks to have been desoldered before. No, it's not failed. Huh. Yeah, it fails sometimes. Well, let's test the 7712 MOS. That's the 7408. Well, it passes. Yeah, I'll replace both those chips. They look to be a little bit suspicious. Really? No, just a bunch of vertical stripes. What the heck is wrong with this machine? Everything is faulty. What has happened? Okay, I got a little bit tired of this machine now. What seems to be a short video for you is actually many hours work for me. All the chips are now in sockets, these chips, except the color RAM, but I don't think there's anything wrong with that. Colors seems to be okay. So there is what looks to be normal signals on all addressing lines and data lines. That indicates there's no broken trace. So what we're left with then is the RAM. And of course the two CIA chips, but I have never experienced that two CIA chips could result in such faults. But I guess it's possible. But am I really gonna have to desolder all the RAM chips? I checked all the input and output signals to all the RAM chips, and they look alright. Apparently this machine won't reveal its fault that easily, but I'm not giving up that easily, so I have no choice but to start removing the RAM chips. I was thinking, well, since it's running code from ROM, from the cartridge port, the addressing and data bus must be working correctly, otherwise the CPU wouldn't run code. The 4 RAM chips are out, and I already found some with faults. This one starts off, then failed. How about this one? How many chips have I replaced now on this motherboard? Yeah, that one tested okay. This one then passed. Okay, so we have one failed so far. Yeah, replace that with a working one. Yeah, I kind of expected it. No change. But off cam I tested a little bit. If I take out one RAM chip and then turn it on. You see now the DesTest actually performs as it should by indicating faulty RAM chips here, and you can see the last one here is red, the one I took out. However, inserting a RAM chip makes it not work. Let me try and pull out another one, number 7. Yeah, that's number 6. Why? So this I really don't understand. If I take out the 2 RAM chips then, yeah, now it shows 2 red. Alright, I don't have any choice. Solder out the remaining 4 RAM chips. Okay, I desoldered the RAM, and believe it or not, there was actually one more of the RAM chips that were faulty. So let's see now what happens here. I replaced it with a working one. Well, it's different, but still not good. My God. Try the dead test now. Yeah, it blinks twice, and that's the indication of a faulty RAM. So maybe one of the chips are still faulty or got damaged now. Well, then I simply don't know. Could it be the CIA chips doing something nasty? I find that hard to believe. Could it be some broken trace or something somewhere on the board? I looked everywhere, I couldn't see anything obvious. And these chips here, could it be something with those? I mean, this only has to do with clock generation and stuff like that. Yes, the pictorial 64 guide, it definitely shows that you can get the graphical glitches with a CA chip fault. So I'm gonna desolder those chips now and see if they're bad or not. Yeah, the CIAs are out, and I'm gonna test now with the machine without them first. Oh no! It's still the same fault. What the heck is wrong with this machine? I give up. But with this test in, I realized something. There's one black line on the second line here. I didn't really check what that means. Now I took out one RAM chip just to make it work. Yes, and reading the manual actually says that the colors of the border indicates a fault. If it's blue, it's a fault with the 0 page. And the stripes indicating the fail address and failed bits. Yeah, so this is good information. I didn't really read this because I was gonna test the DesTest switch afterwards, but a failure during either of these tests, 0 page or stack page failure. Blue, 0 page fail, and the border stripes indicates the fail address and failed bits. The border stripes show address bits, top to bottom. Oh my God, I see my mistake now. You probably can't see it. It's these 2 chips. The label is not easy to see. These are supposed to be 74 LS257 chips, and I have inserted 2 LS157 instead. Dang! Well, it's an honest mistake, but at least it led to me installing a bunch of sockets on this motherboard, which is helpful for the next repairman. Let me find a couple of 257s, and yeah, these chips are very hard to read. I mean, and they seem to have been scratched on top. Yeah, you see there, 157. But they were bad, that's why I replaced them. Well, I certainly learned a lesson. Always check everything. Let's see now. But there certainly were faulty RAM chips, so that wasn't for nothing. But I might have come off without replacing or taking out the CIA chips. Let's see, yeah. Oh, okay. Now we see the DesTest checking everything. Yeah, so that flickering of the border is normal when all the RAM is working. If RAM is not working, then anyway, if the multiplexers for the RAM is not there and instead replaced with a completely different chip, then of course all kinds of strange things can happen. Yeah, and I got myself a break here, and I actually saw a video. The DesTest Switch actually had an issue with if you used unoriginal or cheap logic chips in it, it could get an unexpected break, but I'm not sure if that's the issue here. All the chips I have in is original. But we already tested the DesTest Switch a little bit, and there's no more RAM faults. Okay, now the ROMs are in. Let's see now if it works any better. Yes, look at that. Finally this thing is working. Yeah, I didn't insert the CIA chips, that's why there's no cursor. Insert those. See if this machine is finally working, but there still could be some non-visible faults. Yeah, now we have a blinking cursor. Okay, yes, finally I'm happy this machine is now working. That was a lot of work. Now I can try and run the DesTest MAX-Switch again. Yeah, it seems to be running fine. It's kind of fast switching screen, so it's kind of difficult to have time to read all the information. But the CIA clocks are okay. The instructions go so fast I can't even read it. Basic ROM checksum was red, so that might indicate a fault with the basic. Anyway, no RAM faults or anything like that. Yeah, let's check with the Donkey Kong cartridge. Yeah, as expected, there's no sound, so dead. Dead SID chip as well. How many chips was dead on this machine so far? 6 or 7? But at least that works. I'm gonna run the diagnostics cartridge with the full harness, so I get the full diagnostics now. Because apparently now the machine seems to be working, but it could still be faulty with regards to tape or floppy disk drive, I/O stuff. Joystick ports could be faulty. Do you have any more issues with this machine? Well, it says PLA test bad, but U18 bad. Well, that's the SID chip. U17, that's the PLA again. So, and basic ROM is bad here too. Well, look at that. Oh, bent pin. But still, it booted into basic, so it kind of worked. Hey, look at that. Now I inserted the basic ROM again, and the PLA test now passed, so it apparently depends on the basic ROM. Yes, and now we only get the control port and interrupt bad. I think those are related to the SID chip. I'll find a working SID. Yeah, I found one here. I'm not sure if it's working. Yes, we have audio. However, the U1 and U2, the CIA chips, they turn up bad sometimes not. Both the clocks are the same, so that time function is working. I mean, serial was okay, and that's also powered by the CIA chips. Use a little contact cleaner. Yeah, it's kind of black. You can also use some rubber just to rub them off. They get quite shiny by that. That's an old retro computer nerd trick. No, only you two. Oh, no. Okay, let me find a couple of chips from a working machine. Yeah, I figured this starts getting boring now, and definitely I'm not gonna have time to look at the other machine in this video, because otherwise this video won't be finished in time. So that machine just has to wait. I'll make another video with that. Okay. We get the same, but everything related to the CA chips is okay. I mean, keyboard, control port, serial port, user port, timers. So I'm wondering, is this some incompatibility because of the PLA replica? Yeah, I found another SID chip, and that one is working as well. I'm gonna replace the PLA. I have another variant here based on the 2 GAL chips. I don't know if this is any better or more compatible. Let's see. No, still the same. It could be the CPU, because the CPU has some I/O pins that are connected to the CIA chips, I think. So the CPU could in theory otherwise be working, but making the CIA chips look like failed. It's kind of a weird socket too for that one, so no, still the same. Well, I think I give up. I tried different CIA chip and I tried different CPUs, but the machine seems to work just fine. I had this problem before with the testing harness. I'm not really sure if it's some electrical fault or something with that, but I got some tests that was faulty, and everything on the machine still worked. So, hello, Adrian. I could of course have left you in this video with the blue Commodore screen, booted machine, and then just said it was working, but I want to have it completely fixed, and I want to have it working 100%. But this time I can't prove it for sure, but I can test the machine. Does it work? Can I play games and stuff? Can I load something? And apparently I can. Yeah, for sure the joystick works. It's kind of slow. How about the keyboard? Well. That's a really bad keyboard, yes, but electrically it is working, but all or most keys are. Okay, I need to look at the keyboard, but this video is really dragging out. Fixing a keyboard is quite easy. Yeah, I just want to make sure that it's the keyboard and not the machine that's faulty. I have another keyboard. It might not be working very well, this one too, but yeah, this works. Yeah, so definitely a bad keyboard. So I want to hook up a floppy disk drive, but I'm using this SD to IC. It's easier than using a regular old floppy disk drive. Yeah, it's not particularly good, this keyboard either. I need to push relatively hard. 8. Loading. Yeah, it loaded. So we're gonna run. So you can see that the CA chips seems to be working just fine. You can use the floppy disk drive. Space Taxi, one of my favorite games of all time, at least on the 8-bit machines. Hey Taxi. So the goal here, if you don't know it, is to drive the Space Taxi, pick up the passenger and take him where he wants. Up, police, he said. But of course you need to be careful when landing, not land too hard. well, I think that was it for this video. It became very long. That was kind of a hard repair, but I made it in the end, and I also got to make and test out the DesTest MAX-Switch. Nice cartridge. The keyboard I will take a look at and fix some other day, but the other machine, which I said I was taking a look at, it has to wait simply because this video became too long. Still, I hope you enjoyed the video, and hope to see you again next time. And thanks for all the subscriptions and for all the likes, and a special thanks to my patrons. See you, bye bye. Don't forget to subscribe.